There are many situations that can be described using quadratic equations, and one specifically is physics situations where you either drop an object or throw an object. So this question says a ball is thrown into the air from the top of a building 65 feet above the ground. Its initial velocity is 8 feet per second. The equation h of t equals negative 16t squared plus 8t plus 65 can be used to model the height of the ball after t seconds. About how long does it take for the ball to hit the ground? What is the maximum height the ball reaches? So we don't have to create the equation. There's kind of a lot of information, but even though they threw out this information, they just gave you the equation. And if that's the equation that can be used to model the height, we can answer these questions using this equation. You can solve quadratics multiple ways. You can factor, you can complete the square, you can use quadratic formula, but if possible, the easiest way is to graph. So we're going to take this and type it into the Desmos graphing calculator. Most of the time you have to use f of x for Desmos, but you can always try with the letters they gave. So I'm going to try with h of t. I used my keyboard instead of this Desmos calculator keyboard at the bottom, but it equaled negative 16, and I'm going to use my keyboard for the letter t, squared, plus 8t, got to use my keyboard again, plus 65. So it did graph it. If you're unsure if those letters will work, you can always just convert it back to an f of x. F of x will always work in the Desmos graphing calculator. So if you try different letters and it doesn't show up, you're going to have to replace them. And, oh, I hit a T instead. Let me fix that. You're going to have to replace each one with the f of x and the x to get it to graph. So you'll notice that we can't see the whole picture right now. When we're working with real-life problems, we have to take into account what actually is important for this problem. So when you throw an object, you only care about the time moving forward. -2, we don't care about this area, the time on the left, so we're going to move our graph because we don't care about negative time. But we do need to zoom out a bit. We're going to have to adjust a lot because we want to see the top of this graph as well. Getting closer, here we go. Now we can see the whole thing. The first question said, how long is it going to take for the ball to hit the ground? Well, when we look at our quadratic, the ball hits the ground, and you can kind of see it visually. If you throw the ball up in the air, it's going to hit the ground down at the x-axis. This is the 0 or the root. So it's 2.281. We're going to round to the nearest tenth, which is 2.3. We have to decide, is this the time or is this the feet? Well, our x values or our t values, we had to replace one or the other to get it to graph. T values stood for time, so this x-axis or this t-axis, that's actually our time, 2.3. So the ball takes 2.3 seconds to hit the ground. It also asks, what is the maximum height the ball reaches? That's going to be the top value of the graph. Now these are pretty close. If you want to change your graph again and make it even a little bit better, we're okay with how tall it is, but we wish it wasn't so skinny. You can go to this wrench icon to the graph settings, and on the x-axis, instead of the x-axis being so big and going to 154, I'm going to change it myself and change it to 5, and now we can see the whole graph, but it looks a little better. So we want that maximum value, 0.25, 66. So we wanted to know the maximum height. 0.25 is how many seconds it takes to get there, but 66 is the actual maximum height. And that would be 66 feet, because they stated in the question that it was feet. And our initial value, that y-intercept, that was just the initial information. We started 65 feet in the air. So this at 0 seconds is 65 feet. So there's our key points on our word problems for our graphs. We had when we hit the ground, that's 2.3 seconds, we're at 0 feet because we hit the ground. We have the maximum after 0.25 seconds, we're at 66 feet, that's the highest the ball goes. And we have the initial value, we started at 65 feet in the air when we were at 0 seconds.